So in this video, I'm going to cover 3.3D, graphing exponential functions. And I'm going to answer the essential question, how do I graph exponential functions? So first, let's look at the format. So we're going to have your f of x equals a times b x minus h plus k. So essentially the same thing, except you're going to have your h up here in your exponent and then your k in the same position that you were used to with the other functions. And here would be an example. F of x equals 4 times 2 over 3 x plus 1. All right. And you can tell this b right here, if your b is greater than 1, you'll be increasing or have exponential growth. And if your b is greater than 0, less than 1, you'll be decreasing or it'll have what it's called exponential decay. So your asymptote, you're going to determine. So you're not going to do a axis of symmetry. This isn't a symmetrical function, but you're going to figure out your asymptote, which is a horizontal line, which is basically where that function is approaching, but it never quite reaches. And it equals k. So y equals 1 for our example. So you're going to start your table here in the center with your y-intercept. Instead of a vertex, you're going to figure out your y-intercept. So how do you figure out a y-intercept? It's exactly the same way we learned it before. You're going to replace x with 0 and solve for y. So put 0 in your function rule. 4 times 2 over 3 to the 0 plus 1. So remember, anything to the 0th power is 1. So what's 4 times 1? 4 plus 1 is 5. So our y-intercept is at 0, 5. Okay. And then remember, you're just going to run you're going to go to the left, 2, -1, -2, to the right, 2, 1, 2. And then you're going to take those x values and put them in your function rule. Oops. So we'll start with 1. So you're going to have 2/3 to the first, which is 2/3, times 4 would be 8 over 3 plus 1. And you just start solving each one. So this turns into 3.66 repeating. This turns into 2.77 repeating. 7 and 10. But let's do a negative exponent just so that you can see how this works out. So -1, -1. You're going to have 4 times 2/3 to the negative first. So I'm going to flip it to the first power. So I'm going to have 12 over 2, which equals 6 plus 1. That's where I get my 7. Because remember, this turns into 12 over 2, which equals 6. So I'll have 6 plus 1 equals 7. I did it twice in a row. All right, there we go. 6 plus 1 equals 7. Remember, I do this by flipping these two and making my exponent positive. So 3 over 2 to the first. Okay? All right, and then you would go ahead and graph that function. So let's do another example. Let's do example number 1. So first, you're going to start by figuring out your asymptote. Well, y equals k. Well, there's not a k here, so it's going to be 0. Then you're going to fill in your y-intercept. So with exponential, you're always going to have a 0 there in the center. And then you'll go -1, -2, 1, and 2. So let's put 0 into our function rule, which is going to equal 1, because anything to the 0th power is the number 1. So our y-intercept is 0, 1. Great, let's figure out our other. So I'm going to have 1/2 to the -1st. Again, you're going to flip it. So this would be 2. Okay. And then I'm going to have 1/2 to the negative power. So I'm going to flip it. So I'm going to have 2 squared, which would be 4. Okay. This would be 0.5. Because I'm going to have, 1/2 to the first, and then I'm going to have 1/2 to the second, which would be 1/2 times 1/2 equals 1/4, so 0.25. All right, and then you're going to want to graph it. So our asymptote is y equals 0. It's a horizontal line, always horizontal. We're not going to do a vertical line for an exponential. Then you can graph your y-intercept is right there, okay? -1 would be at 2, 1, 2. -2 would be at 4, right there. And then 1 would be about 0.5, and then 0.25, okay? And then you can draw your function, making sure you don't have it touch the x-axis, because it doesn't. It never touches that asymptote. So make sure you're graphing it correctly. So domain, it's going to go from left to right. It's going to go from -infinity to infinity. And then your range, so from bottom to top, it's going to start at my asymptote and go up to infinity. All right. Let's do number 2. So again, start with your asymptote, which is your k. So y equals 5. Then you're going to solve for your you're going to do the calculations for your y-intercept. So 2 to the 0th power is going to be 1 plus 5 equals 6. Okay, I'm going to have a -1, -2, 1, and 2. It's always going to be like that on your exponentials. The list of x's aren't going to vary because you're always starting with your y-intercept, which the x is always 0. Okay, so I'm going to have a 0, 6 here. Then you're going to fill in the rest of your numbers. So 2 to the first is 2 plus 5 is 7. Then I'm going to have 2 to the second plus 5, so 4 plus 5 is 9. Then remember when you're doing your negative exponents. So I'm going to have 2 to the -1st, which is 1/2 plus 5 would be 5.5. And then it would be 5.25. Okay. And then you're going to want to graph it. So start with your y-intercept. I usually start with my y-intercept, which is right here. Okay, and then I'm going to graph my asymptote also. So you should start with your asymptote, I should say. Y equals 5. Then graph your y-intercept. Okay, so the number 1 is at 7. Number 2, it's at 9, which is 5, 6, 7, 8, which is right there. And then you're going to have Negative 1 is 5.5, which is about right there, and then I go down just a little bit more. And then you can graph your curve. Oops. That's what I did wrong. Sorry about that. That's why it looks weird. That's supposed to be at 7. All right. Then you can graph your curve, making sure I don't hit that asymptote. It doesn't go past the x-axis. Be very neat with your graphing. It's going to be negative infinity to infinity. And then the range from bottom to top, again, I'm going to start here with my asymptote, and it's going to go up to infinity. All right, I'm going to do one more, and I'll leave the last one for you. Again, my asymptote is my k, so y equals negative 2. I'm going to solve for my y-intercept, so I'm going to replace x with 0, 0 plus 1 minus 2. So I'm going to have 2 minus 2, which is 0. So this one is actually going to start at the origin, and then I would have 2 minus 1 plus 1. So it'd be 2 to the 0th power, which is 1 minus 2. So this is going to be at negative 1. So it would be 2 to the 0th power minus 2. So 1 minus 2. That's where I get that negative 1. Then you're going to plug in your negative 2. So 2 minus 2 plus 1. So 2 to the negative 1. Minus 2, so you have 2 to the negative 1 minus 2. So I'll have 1/2 minus 2. And that's where I get negative 1.5. So then I'll have 2 to the first, which is 2 minus 2 is sorry. That's not what I'll have. I'm trying to do it too much in my head. So I'll have 2 to the second minus 2, so 4 minus 2. I will have 2. And then I'm going to have 2 to the third. So 2 times 2 is 4, times 2 is 8, minus 2. And I will get 6 here. Okay? So your y-intercept is 0, 0. So start by graphing your asymptote here at negative 2. Okay. Then I'm going to graph my y-intercept 0, 0. And then I can do negative 1, negative 1, negative 2, 1.5. And then I can do 1 is 2, and 2 is 6. All right? You can graph it just like that, making sure I don't hit that asymptote. So my range would be negative infinity. My domain would be negative infinity to infinity. And my range, again, start with that asymptote to infinity. There you go. All right. So if you're having trouble, especially if you're having trouble filling out your table, doing your calculations with your function rule, or you're struggling with negative exponents, please come and see me. But start with number 4 and then move on to your assignment.